We will label the acids, and the acid and base, and the conjugate acid and base. So this would be the base because it has a negative charge, which is a red flag, and it will be the compound accepting the proton. And in the same way, this would be the compound giving a proton and receiving an electron pair. So that's the acid. And for the conjugate acid and base, it's the same. This compound is giving a hydrogen, this one, over there, and this is the base, has a negative charge, and it will exchange this electron pair for hydrogen. And the electrons will flow in this manner. This electron pair will go to one of these two hydrogen atoms, and then transfer to the nitrogen, which would free the hydrogen, and that will bond to the sulfur. And that will create these two products. This compound with an SH group there, and this compound with an NH group there, which is negatively charged as the base. And now to decide which would be stronger or weaker, we can use this ARIO acronym to help us, which stands for atom effect, resonance, induction, and orbital effect. So to begin with, let's look at these two compounds. This sulfur has a negative charge, but it would be able to hold that negative charge better than this base, because sulfur is larger than nitrogen. It's down one row, and it's also closer to the right of the periodic table, which means it's closer to getting an octet, and it will be happier with a negative charge. So because, and for the other three factors, resonance and induction, there would be an induction effect in each case. However, it won't be nearly as important because it's far away to begin with, so it should be a weak induction effect. And it's further down in the acronym, so it's not as important as the atom effect. And there shouldn't be very much resonance, and it is kind of far away from the charged atoms, so that also won't matter as much. And there will be another orbital for the NH base, but the atom effect should still matter more. So that leads me to believe this compound would be more stable, and because of that, it would be a weaker base. And this would be a less stable base, so it'll be more reactive and a stronger base. And for this acid, when it loses its hydrogen, it turns into this strong base, which means that's a strong acid, and this would be a weak acid, because when it loses its hydrogen, it turns into a relatively unstable base over here. And next, we will discuss the pKa value, because this is a relatively stronger acid. Oh, wait, no. Yeah, this is a relatively stronger acid. It should have a higher pKa value than this acid. And because these two compounds are strong, they will want to react more than the weak acid and the weak base. And because they're reacting more, they will get used up more often. So that makes me think the arrow will be larger in this direction, and the equilibrium will lean to the left. And these two compounds will be in the highest concentration. That's it. Thanks for watching my video.